Grade 12 Physics Unit 1, Thermodynamics 1.1, Thermal Equilibrium and the Definition of Temperature. What is thermodynamics? Thermodynamics, study of heat and energy. Thermodynamics is the branch of physics that deals with heat, temperature, and their relation to energy and work. It helps us understand how energy is transferred between systems and how it affects matter. From boiling water to engines running, thermodynamics explains it all. Now, let's zoom into the first concept, thermal equilibrium. Thermal equilibrium: imagine placing a hot metal rod next to a cold one. Over time, the hot rod cools down and the cold one warms up. Eventually, they reach the same temperature. This state is called thermal equilibrium. Definition on screen. Thermal equilibrium is the condition in which two or more objects in contact with each other no longer transfer heat between them. This means the net heat exchange between the objects becomes zero. Animation shows molecules bouncing fast in hot object, slowly in cold object. As time passes, they equalize. In simpler terms, heat always flows from a hotter object to a cooler one until both are equally warm. That's when they're in thermal equilibrium. Cut to real-life examples. Hand on a cup, thermometer in mouth, ice cube melting in water. Zeroth law of thermodynamics. To fully understand thermal equilibrium, we need to mention the Zeroth law of thermodynamics. Text on screen. If object A is in thermal equilibrium with object B, and object B is in thermal equilibrium with object C, then object A is in thermal equilibrium with object C. This law may sound simple, but it's foundational. It allows us to use thermometers. Let's explain. Suppose your body A is in contact with a thermometer B. The thermometer reaches equilibrium with your body. If the thermometer B is also in equilibrium with another object C, then your body and object C must be at the same temperature. This idea is crucial for defining temperature. Definition of temperature. So, what is temperature? Text on screen. Temperature, a measure of the average kinetic energy of particles in a substance. In hot objects, particles move faster. In cold ones, they move slower. That motion, the kinetic energy, is what we measure as temperature? So, temperature isn't just a number on a thermometer. It's a reflection of how fast molecules are moving inside an object. Here's a breakdown. More kinetic energy equals higher temperature. Less kinetic energy equals lower temperature. And remember, when two objects have the same temperature, their particles have the same average kinetic energy, and they're in thermal equilibrium. When you place a thermometer in a liquid, heat flows between the liquid and the thermometer until they reach thermal equilibrium. Once that happens, the thermometer's temperature matches the liquid's temperature, and it displays the reading. Thermometers work because of the Zeroth law. Without it, we couldn't trust the readings. Here are some everyday examples of thermal equilibrium in action. A cold soda warming up in a room, your hand getting warm when you hold someone else's, ice cubes melting in your drink. Thermometers used in hospitals. In all these cases, heat flows until equilibrium is reached. Let's recap what we've learned today. Thermodynamics studies heat and energy. Thermal equilibrium is when objects stop exchanging heat. Zeroth law helps define temperature. Temperature reflects average kinetic energy. Thermometers rely on thermal equilibrium. Understanding these basics sets the stage for deeper concepts like heat transfer, specific heat, and the laws of thermodynamics. Thanks for watching. Like, share, and subscribe for more.